Algebra 1, Section 12.3, multiplying and dividing rational expressions. I kind of have this paced out here for myself, so this is really not really part of notes, but just for myself to know when to go to an example, when to come back to the starboard here and do an example. So we'll be doing several today. I'm going to start with a couple of basic ones here. And as I've said, I think a few times in the previous couple of lessons, there's maybe multiple ways to do this, and there's kind of value in you seeing both things. So let me first say that on number one, what you might see is when you look at this is that you could go ahead and multiply across. 3 times x squared would be 3x squared. And the denominator, same thing, multiply across. X times 6 could be written as 6x. And then once you have one fraction, you can just look to reduce that. Very similar to the previous lesson in section 12.2. And 3/6 reduces to 1/2. X squared would simplify to x to the first power as you cancel out this one, and you'd be left with just x over 2. Okay. Now, rather than doing that, what I think is probably better for you to see, and again, I think both of them are important for you to see, but I think probably the better method to go forward is to cancel things first. Okay. So rather than multiplying things first, you can go ahead and cancel those, knowing that x squared is going to be in the numerator here and x would be in the denominator over here. We can just go ahead and cancel them now. And this would become x to the first power. This would become 1. 3/6 reduces to 1/2 in the same way as we did it just a minute ago. I'm just doing it before I do the multiplication. Now, you do need to be a little bit careful. Either method, you do need to be a little careful as that you understand what you've simplified it to, right? This is 1, where this is x to the 1, right? So just make sure that you understand your own notation. So 1 times x to the first power would just be x, and then this is 1 times 2, we get x over 2, okay? Similar, but just a little bit more complicated in the next one. 5/15 would reduce to 3/5. Interesting here, y squared would reduce with this y to become y to the first. It would also reduce with this y. So really the y's cancel each other out. And what do we have left? Well, you just have 3x in the numerator. This is 1, so it's like 3 times x times 1. That's 3x. And in the denominator, you would have just 5. This is 3x over 5, or you could say 3/5 x also. Okay? Now over to the presentation software. This is example 1. We're multiplying again. So this is kind of the continuation of 12.2. Obviously, 12.3 comes after 12.2. And that we are now applying what we did in 12.2 to problems that have multiplication, and the last couple examples are going to actually have division in them. All right. So what do? Well, you know how to multiply fractions. You multiply across. So 7 times 8 would be 56. Y times y squared, you add those exponents. So that would be y to the third. And we should look to reduce these fractions, but in fact, this one doesn't. It's just 56 over y to the third. Okay. Same thing here. We're going to multiply. You must realize, I hope you do, that a fraction bar is a grouping symbol. Okay, so they don't always bother to put parentheses around things, but they should be assumed to be there when there's that long fraction bar like that. Okay, so as I multiply x by x minus 2, I can just write it just the way I just said it. X times x minus 2. Okay, and similar in the denominator, x plus 5 times x minus 6. Nothing canceled here, right? There was no factor the same numerator to denominator, so nothing's canceling. We're simply just multiplying them together. And you can go ahead and leave it in factored form too, just like that. Okay. Example 2. I think this is dumb the way they do this, the way they present this, multiply these two things. I think if I roll to the next one, it'll show you what it would look like in the book. Yes. So this is the problem we'll be doing. More closely presented as it would be in your book. Let's not even look at that right here. We'll do that step. Okay. So this would be the type of problem that you'll be asked to do in your book. They're not going to say multiply this and this. I don't believe they'll do that at all. Okay. This is the times dot though. All right. So what do we want to do? What you want to do, and this is kind of the key point to the lesson from here to the end, you want to factor. You want to factor anything that can be factored, because when you do, oftentimes you'll find factors that can be canceled from numerator to denominator. So here you have 3x plus 1 over 4, and you're multiplying that by 8x over something that can be factored. 9x squared minus 1 is a difference of squares. We can write that as 3x plus 1 times 3x minus 1. Don't forget the difference of squares that we learned in chapter 9. Extremely important. Comes up again and again. And as I just kind of stated, now you have 3x plus 1 that you can cancel from the numerator of this fraction to the denominator of this fraction. Please realize that when you have this kind of multiplication, looking at the denominator, you have three things being multiplied. 4 times the quantity 3x plus 1 times the quantity 3x minus 1. In the numerator, you have 3x plus 1 as a quantity being multiplied by 8 being multiplied by x. So yes, you absolutely can slash those out that way. Also, 8/4 reduces to 2 over 1. And I think that's it. So what are we left with? This became 1. This is 2x. That's your numerator. This is 1. This canceled out to become 1, if you will. And then you have 3x minus 1. So 2x over 3x minus 1. Similar example. Again, I'm going to start by factoring. Maybe I can squeeze it in here. I might have to bump up here a little bit, but we'll see. This is x minus 2 over 8. This I could factor out a negative 8. And if you have the opportunity to factor out a negative, I think you should do it. So that's negative 8 times x plus 2. This is a difference of squares, x plus 2, x minus 2. Okay? And again, now once we have it completely factored, we should look to cancel things out. Here's a set of things that you can cancel out. Here's another set of things you can cancel out, x minus 2 and x minus 2. Okay, so a lot of this is all just canceling out. And then negative 8 over 8 would simplify to just negative 1. Right, it's like negative 1 over 1. So this whole thing, right, this became 1, this is negative 1, this is 1, this is 1, this is 1, this is 1. This whole thing simplified to just negative 1. Sorry for the delay there. I was just checking on my checking my answer to make sure I had that right. Okay. Next example on the presentation software. Again, multiply. This is what the problem will actually look like. We don't need to see this right now. We're going to do that step. But again, look to factor. And you know that when you have something that's just written this way as a polynomial, that's understood to be a numerator, right? So as I factor this, I will put it over 1 too. Also, 1 also. This is factorable. There's a GCF of 3. Let's take that out. That would leave me with x plus 4 times, and again, here's another fraction over 1. That'll just help us with the multiplication, with the simplifying and the multiplication, really. And here's something that factors. You've got x and x. I would say 3 and 4 are going to multiply to give you 12 and add up to 7, right? So 3 and 4 both plus. Okay? So what then simplifies? X plus 4 simplifies top to bottom. And I think that might be all. All right, so we're going to have 5x plus 1 in parentheses, right? Again, fraction bars are grouping symbols, so this is understood to be in parentheses, times x plus 3 all over 3. Now, I hope that you're not thinking what I'm about to bring up, but I'm going to bring it up because somebody might be thinking that. Is there any way that the 3 is going to cancel with anything in the numerator? No, there is not. The only way you could cancel that 3 with the numerator is if there were a 3 as its own quantity, right? Not with this that's part of the parentheses quantity that is x plus 3. So this is completely simplified. Okay. And then back to here for a couple of examples. This one, I think we could attack this a couple different ways. You could go about it by distributing and then canceling numerator with denominator because there are the c's there. I think maybe the better approach would be like this, though. Let's go back to blue. Go blue. I could factor out a c from those parentheses, which would leave us with c squared minus 1. Now, c squared minus 1 should ring a bell in your head because that's a difference of squares. So not only will these c's cancel right here, but we should also factor c squared minus 1 into c plus 1, c minus 1. Our answers should be completely factored in that way if possible. Okay, so that's that. Something similar but yet different here in the fifth example. That's factorable. You can also take a 4 out of the numerator here. This is a difference of squares again. I told you that was going to come up again and again, and it is 4 times m plus 2, and this would be m plus 1 times m minus 1. And the m minus 1s will cancel. So what do we have? Basically, you have this right here, right? This is your answer. 4 times m plus 2. Now look, if you distributed the 4, that would be fine. I like to just leave it factored. If you had 4m plus 8, that's okay. I think if you are checking your answers, though, I think they're going to have this. Okay? All right, moving along. Now we're going to get into division. The section was about multiplication and division. Now we're going to get into division. You should recall that back a long time ago when you were given something like this, 2/3 divided by 4/9. What you were taught to do is that divide means multiply by the reciprocal. You were probably taught to change divide to times and then flip the second fraction, right? Then you have a multiplication problem, and then you can go about it. Okay, here's 2/4, that's 1/2. Here's 9/3, that's 3/1. And then you can finish the problem. It would be 3/2. Okay, well, that's exactly what we're going to do in algebra just as well. And now again, not crazy about the way they say this. Here's what we really want. This right here. We're going to do this step. So just look at this problem right here. Flip the second fraction, change divide to times. This is the rule. Also, along the way, you should factor everything that you can. Okay, so here I have something that can be factored into two binomials like so. I'm sure it's plus 8 and plus 5. Those add up to 13, and 8 and 5 give you 40, over x minus 7 times, right? Not divide, but times. By the way, if you need an extra step to do this, if you want to do the factoring first and then change divide to times and flip the second fraction on the next step, or even if you did that in reverse order, that would all be fine. I'm going to do it in one step here. What was my denominator is going to become the numerator, and it's factorable. X plus 7, x minus 7. What was the numerator is now the denominator, and that's x plus 8. Okay? And once you do that preliminary step, or really it's two steps that I did in one. Once you do that, once you get to here, it's very much like a problem that we've already done. And you're going to look for things that would simplify out. So x minus 7s would cancel. The x plus 8s would also cancel. And you got x plus 5 times x plus 7. That's your final answer. Okay. Similar problem. I'm going to factor 5 here, m plus 2 would be left. Denominator, take out a 2. That'd be m minus 10. Change divide to times. Flip the second fraction. You can take a 2 out of this one. I guess it's just 2, right? So 2 times 7m minus 10. And numerator becomes denominator, take out a 7. That would be m plus 2. So m plus 2's would cancel, and I think the 2's would cancel. I think that's it. So 5 times 7m minus 10 over 7 times m minus 10. Yep. 5 times 7m minus 10 is the numerator. The denominator is 7. We should put that out front, right? And then m minus 10. You must be having fun now. All right, one more example. Example 5, and then this one right here, and we'll be done. Still division. Here again is our problem. Ignore this. Factor and change divide to times, flip the second fraction. Factoring, x plus 2, x plus 7, denominator 11x. Divide to times. 1 is now the new numerator. You can take an 8x out of the new denominator. What was the numerator is now the denominator. You can take an 8x out, which would leave you with x plus 2. Okay? And x plus 2's would cancel there to there. And I think that's all. So you're going to have x plus 7 as your numerator, as you put them together, as you multiply, over 88x squared. Yep. And I'm glad that they sometimes give us examples like this that seem a little bit weird. Things didn't simplify as well in this one as sometimes they do. But what you get is what you get. X plus 7 over 88x squared. Sometimes when I get a weird answer, I do get a little bit worried that I've made a mistake, and I go back and check. Well, that's a good thing too, right? So go back and check if you think you've done something wrong. Look at it with fresh eyes if you can. All right, last example we're going to do is this one right here. And the only reason that I put this one here, because the other examples I had to choose from in the book were pretty similar to the one we just did, is that this could be a little bit of a deceiving one, okay? It could be really easy to look at that and go, aha, the y plus 2's cancel. Okay, but they don't, because this is division. This is y plus 3 over y plus 2 times the reciprocal of y plus 2, which is 1 over y plus 2. So what is it really? It's y plus 3 in the numerator, and then the quantity y plus 2 times itself, or you can just say squared. Y plus 3 over y plus 2 squared, in parentheses, right? All right, that's all. Thanks for tuning in.